Alright, welcome back. In the previous module, we work with topics. We create publishers and subscribers, and we saw how ROS2 is great for continuous data streams like joint position or sensor values. But now there is an important question. What if you don't want a continuous stream? What if you want to ask for something specific and wait for a clear answer? For example, to open the gripper or to close it, reset a system, or get the current status. This is exactly why services are coming in. In this module, we explore a new communication pattern in ROS2 services which are based on request and response. Unlike topics, services are transactional. You send a request, the server processes it, and you wait for a response. The key difference is topics are asynchronous and continuous. Services are synchronous and one-shot. It's like a request and a response. For this module, we're starting a small but realistic robot arm project. We follow ROS2 best practices and split things properly. One package for interfaces, where we define our services, one package for control, where the Python nodes live. This separation is very common in real ROS2 projects. The first thing we do is define a custom service called gripper control. It accepts a string command like open or close, and it returns a boolean indicating success and a message describing what happened. This point SRV file is the contract between client and server. The request goes on top, the response on the bottom, simple and explicit and predictable. Once the service is defined, we build the interface package. This step is critical. If you skip this, Python won't be able to import the service type later. Trust me, this is a common beginner mistake, so don't skip it. Next, we create the service server, the part that actually does the work. The servers wait for request on control gripper, reads the command, executes the logic, sends back a response. In our example, open opens the gripper, close the gripper, anything else return an error. This simulates real robot control logic, just without hardware. After that, we create the service client. The client's job is straightforward. Send a request, wait for a response, continue only when it gets an answer. This blocking behavior is what makes services powerful. You know whether the action succeeds or failed before moving on. Once both nodes are ready, we register them in setup.py. This lets us run them with ROS2 run, just like any other ROS2 node. Then we rebuild the workspace and source it. Now we open two terminals, one to run the gripper server and the other to run the gripper client. We can try the commands like open, close, and thence, for example, that will be an invalid command. So why not just use a topic for this? With a topic, you publish open and you hope it works. No confirmation, no feedback, no guarantee. With a service, you request an action. You wait, you get a definitive answer. This pattern is essential for robot orchestration, sequencing, and making reliable decisions. So, in this module, you learn what services are, when to use them instead of topics, how to define custom services, how to build a service server, how to build a service client, and how to test everything using CLI.